Hello, this is Dr. Carroll. Today's video is about pointers. All right, to set some groundwork, we need to talk about two operators. First is the address of operator. And what does it do? It returns the memory address of the first byte in memory of a variable. Okay? It's the first byte in memory. So it returns a memory address. Often that's a hexadecimal is how it's represented. It depends on the system how long it is, but it returns a memory address. So that's what it does. The other one is the dereference operator. And what it does is it dereferences a variable. Okay, now if that's not terribly clear remember this is a review, we'll get into it today, and if it's not clear after this video, you need to look that up. Okay, so what if we had something like int pointer? What does that mean? What it means is that pointer is an address, or you could think location, of an int variable. That's what it's going to store. It's the address somewhere in memory, the location of an int variable. Okay. And what does star pointer mean? Dereference pointer is the same as that variable, that int variable. When we use star pointer, it's the same as whatever it's pointing to. So Dale and Weems in their book say that pointers are variables that tell you where to find something else. So here's an analogy, and hopefully this will help you. Imagine that a P.O. box is like a memory location. Okay, so post office, you know, that place people used to go to send mail, and it's where you can store things. But for a pointer, and imagine what you might find in a P.O. box would be like a will, your parents' will. Hopefully you don't need that. And so instead of having a P.O. box that contains the will, that variable in there, the analogy would be the post office box. You open it up and it has the address of another post office box which has the will in it. So it has the address of where to find something. So it has the address. How do we assign that? To assign an address, you got two options here. You could use, say, for example, pointer equals address of a variable. Let's just declare it right there. Okay, so that's going to take the address of x and assign it to pointer, with pointer, as declared up above, stores an address. There's another option. You could take pointer and you could say equals a new int. And by the way, that's on the heap. Okay? If you want to allow the system to reuse memory, you need to use delete. So you could say delete pointer allows the system to reuse memory. Okay, and what that means is now the value of pointer is undefined. Okay, so imagine we have int x, we have a variable p, I'm just making these up, q, we have these three variables. And we have some memory contents. Oh, let me try that again. Okay, so we have this in memory. Okay, and so let's step through some instructions and see and put them into memory. So if we have these instructions here, let's execute them. Okay, so int x. Okay, so what we're going to say is that when we declare that, it's going to be set here. So here's int x, we'll do the type and then the variable name. And then in memory, and this is just a memory address, I just made it up, by the way, that's not valid. The memory address has to be much higher, but just ignore that for right now. But so it's a memory address, and the clue is that it's hexadecimal, that's the 0x. This is base 16, in case you haven't come across hexadecimal before. So each value you multiply by 16 to raised to the power of its position. So x would be assigned to here, and it's of type integer. We have an integer pointer, so it's going to be the address, and we're going to call that p, and then here is q. And we're going to end up using these memory locations, but they're at the opposite end. So here we have p equals the address of x. Okay, well here is p. This is the memory location for p, and we need to store in there the address of x. Okay, so the address of x is hexadecimal 10. Okay, now we say we're going to dereference p and set it equal to 7. So what we do is we come to p and we say, okay, we need to dereference it. It's pointing to something else. Now we're going to go here and we're going to assign 7 to that. Okay, so we just did that here. Moving on, now we're going to have p equals a new int. Okay, so when we call new, we're going to get it on the heap, and I've illustrated the heap here with this ellipses. This is the opposite end of memory where we are. And notice it's an int, but notice I haven't named it. It's anonymous. So we're getting an int, and now we're assigning p to that. So that means we're assigning, it's a memory location. Good, p still a memory location. But now it points to this anonymous int. It's not named, but we have a pointer to it. If this was a whiteboard, I'd draw an arrow from here over to here, but that's what this means, is we've stored the address of. So that's what we've done with here. Another video in dynamic memory, we cover new in much greater depth. Now, notice we just dereferenced p before and assigned it 7. Now what happens when we dereference p and assign it to 9? Okay, so while we dereference, we say, what is the address here? Okay, I'm going to go to that location that's here, and I'm going to assign it to 9. Okay, so that's what we just did here. We dereferenced p, the location, assigned it to 9. Okay, with me? Any questions? So here, is this valid? It is. We're taking a pointer and assigning it to another pointer. These are addresses. The pointers are addresses, so we're just taking the address here, and we're just going to copy it over into Q. And we've copied it over. Now the very next thing we did is overwrote it again. Okay, so what we do last time? So we're getting a new int here to execute this. Again, it's anonymous, and we're going to assign that address here in Q. Q is an address of a memory location. Here's the memory location. Now, what's in this memory location? We don't know. It hasn't been assigned. It's garbage. It's random. We don't know. It's undetermined. Okay. So that was this step. Now, what happens when we dereference P and we assign 11 to it? We go to P, we dereference it, and we assign 11 here. Don't be confused about this statement earlier. We've overwritten it. We dereference P, 92. We go look up in memory location 92, hexadecimal, and we assigned 11 to it. Okay, that's what we've done here. Now we assign P to null. You might need to include a library to get null. It just depends on the environment you're in, but often you don't have to. So we assign P to null. Okay, where's P? P's here. Null is 0, and we represent with hexadecimal to suggest that it is a memory location. We might write null there. They have the same meaning mostly. Okay, and so that's what those instructions do. Now notice what P setting it to null didn't do. Let me feel better if I put this in parentheses here. Okay, so that's what that means. Notice what setting p equal to null didn't do. It didn't do anything about the memory address, the memory location here. It just left it. Watch for that. I'll come back to that in another video. Okay. Now, there's something else we need to do here, just for illustration purposes. Let's delete Q. Okay. So deleting Q says that we are freeing up the memory that Q points to. Okay. So now it's no longer assigned to that memory. But notice what it didn't do. It didn't change the contents here. It just freed up that memory. It says, hey, it's available now. But it did not change the contents here, and it did not change the contents here. We have to do that with other statements. Okay. This code right here is also available in a file right here, so you can see it and you can execute it and it'll print it out. That's chapter 1 pointers CPP. You can run it, play around with it, run it through the debugger, and enjoy it. What would be good is to run pointers B, run through that, and make sure you know that and that it works well. All right? Great.